Welcome to my presentation of VHDL Testbench. Previously, you have seen the schematics drawing and how to do that. So in your first lab, you have to complete these gates, logic gates, using the De Morgan's theorem. So right now I have drawn all the circuits in here, as you can see, and now I'm gonna implement the simulation of VHDL Testbench. In order to do that, you need to add a source in the existing schematics you have. So this is the schematics we are talking about. Now we have to add a source to implement the test bench. So let's see how to do that. First, you have to select this one, and then you can click to add a source, or you can put a new source in here. So let's go to that one. As you can see, a new window pops up. In this window, you need to select VHDL Testbench, and the file name, you can put a name on it. For example, I'm gonna put main_2, and then click next. Okay, so I have something. Yeah, I need to paste it. So then click next and finish. So now we have the module for the test bench to implement that, and we have the components like for ports you have from the schematic, and then you have the signals. Those are the classes of signal, where the A, B, C, and those other ports are the concerns of the STD logic. That means the standard logic gates. So now, in order to implement your test bench, you need to do something like you need to instantiate these ports, right? And also you need to put some kind of period for your signals. So to do that, let's see first the instantiation, which is which we can start from the signal A, right? So in order to do that, we can have, as you can see, this logic gate, the standard logic gate variable in here. It has this attribute as a data type of a string. So let's put a string on it. So the default value we're considering is 0. So you just put it there. And also remember, these signals, the signals we need to have those default values are the inputs, right? Because we don't need to put all default values to the output, right? Because the output depends on the input, and this is a combinational circuit. So in that case, we have to have the values for input only. So let's copy this one and paste it for B, because we have the same value, right? And for C, it's the same. And X is our output, so we don't need to worry about that one. And Y is also our output. X1 is output, Y1 is output. Now, what do we need to worry about? The last one. The last one is the input, right? So put it there as well. Now the instantiation is done because we have all the inputs. They're starting from 0, right? And then what we need to worry about, this is the the test. So these are the outputs and input port map. And we don't need to worry about this one. The next, you need to do the test bench in here. So how do you do that? So let's say, as we have seen, or as you have seen, you have watched the video about the clock, right? In that previous video, you saw how to force the clock so that you can have the outputs. And that in order to have the period, you need to know about the frequencies, right? So, and you have also studied, or you have already known about that. So I'm not gonna go over to that again. So in that case, I'm just gonna have the process so that you can have, or you can put the value for the period, like how do you put the wait time for your input ports. So let's say it's the short name for test bench. So we have what? We have 4 output, right? 4 outputs like A, B, C, and D, right? So we have to make sure that we have individual process for each of the input ports. So for that case, first we're gonna rename it like TBA. That means it's for the port which has name A, right? So then we have to make sure that it will wait for example, we're gonna have 200 nanosecond in here. So it's 200 nanoseconds, and it's gonna wait for 200 nanoseconds. Okay. Now this is the process, and now we have to also make sure that our output, as we have studied, we knew that from our previous course, like the microprocessor 1 lab, right? On that lab, we have studied that for any kind of clock, we need to assign our port with the inverter option, right? So in order to do that, I'm gonna assign a port. Sorry, this one, and then B, A, right? Okay, so that's how we learned about the clock in the previous course, right? So we do that, and that's all for the port A. Now we have to repeat the process for each of the other 3 ports, right? So let's go over to that. Let's copy this one and paste it under that. Let's hit this one. Okay, so yeah, this is good. So it should be B. And now we know the frequency, right? We have to put it at half of the previous one, right? So that in that case, we should have 100 nanosecond, right? And this one should be 100 nanosecond. And this one should be B, right? So that's okay. Now it's done. Let's go for the port C. Copy that one because they're the same, right? So we don't need to write it again. So this one should be half of the previous one, half of the port B, right? In that case, we have 50 nanosecond. 50. And this one should be C. That's for the C port. Now the last one, we can process that one. Okay, so let's change it to D, and it should be 25 nanoseconds, right? Oops. Second, this one should be B. And this one should be the end of the process. And now we have the test bench ready for simulation. As you can see, these are the four ports to simulate the clocks. And we need to check it first, going to that simulation part. You need to check this one and go to this one, and you'll see this ISE simulator in here. So first of all, I'm gonna check the behavioral syntax. Let's double click on it. So don't worry about the warning because it's about the Verilog file. So we don't need to worry about the Verilog files because we are only talking or only learning about the VHDL code. So that's all right. Let's move on to the next part. The next part is the simulate behavioral model. So double click on it. And then you should see a window pops up. So here's the window that has been popped up by the simulator. So in here, you can see the clock signals in here, but we cannot understand what's going on, right? So in that scenario, you need to change the period for the observation. So in here, we're gonna check with, we're gonna test it with 200 nanosecond. And now let's play it a little bit. Still, you can't understand. So in that case, we need to use the zoom to full view. So click on it, and then you can see the whole clock signal for each of the ports. So as you can see, if I drag the cursor in here, you can check all of the outputs for the ports. So in here, for example, if we check the first one, I mean the first circuit we have, the AND gate, and you can check the value for the output as well in here. So in here, it's just the clock signals. You can maintain you can test the signals using the VHDL Testbench, and for that part, you need to assign the process for each of the ports, for each of the input ports. For each of the input port, you have to have a process where you can assign the input ports so they can have these clock signals. As you can see, the clock signals are having the signals in here, and then you can check the output as well for Y. As you can see, I think it's the OR gate, right? And those are the other signals for the output. So you can drag it and see what's the output. And as you can see, the values are changing in here, right? So that's how you're gonna check the values for output, each of the outputs we have for our logic gates there. So remember that, let's go to that one. Like I have to tell another thing in here. So in here, as you can see, these codes, actually they're not case sensitive. So it's not mandatory that you have to put all caps or all small letters. So this code, the language, it doesn't have the case sensitivity. Okay, thanks for watching. This is it. And this is the way you can check the output for the clock signals. And you can check the output signals from the force clock option in the schematic as well. I mean, the schematic has also the schematic also has a simulator option, so you can do that too. But if you want to put or if you want to see the clock signals using the test bench, you can do this. You can do that coding and check these signals out. Thanks for watching.